Hello. Today we're going to be talking about the Pythagorean theorem, and we're going to start with proving the Pythagorean theorem. In a right triangle, the two sides that form the right angle are called legs. And so here's our right angle. And if I look at the two lines that form it, the two lines are called legs. And they can be labeled as A and B. The side that is opposite the right angle, so directly across from the right angle, that is your hypotenuse. And a lot of times we label that with C. In a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So what they're saying is, if I square my legs and add them, so the sum of the square of the legs is going to be equal to the hypotenuse squared. Okay? Now let's prove it. It says, draw a right triangle on a piece of paper and cut it out, making one leg shorter than the other. And that's what they've done right here. So this one here would be our original, and we've cut it out. And then we're going to trace that triangle onto another piece of paper 4 times. And so what we have are 4 triangles that should be the exact same size. Okay? When you put them in this format, you'll notice that the center forms what looks to be a square. We're going to label these, and so we have, it says label the shorter leg A and the longer leg B. So this is A, this is B, hypotenuse is C, this is B, it's the longer, this one's the shorter. Well, this is the long leg, the short leg, long leg, short leg, and then the hypotenuse is C. Okay? What is the area of the unshaded square? Well, when I do this, what do we notice about the length of this side? It's the same as the hypotenuse, right? And we know the area of a square is side squared, right? So if the side is called C, so the area of this square, in this case, is going to be C squared, because C times C is C squared. So it is going to be, C squared. And so this whole thing, I'm going to change the color here so we can see the difference, is C squared. Then it says trace the original triangle onto a piece of paper 4 times again and arrange them as shown below, and draw a line outlining a larger square that is the same size as the figure you made in B. So this is our same size of our square up here. Okay? And then we're going to label the sides A, B. This would be B, and this would be A. That's A. This would be B, A, and B. Okay? And then they labeled the C's for us. So what is the area of the unshaded in the top right of the figure? So they're talking about this box right here. And so if I wanted to find the area of this box, how would I do that? Well, again, we know that this side it's square. And so this is an A, this is an A, and we know that the area of a squared is side squared, right? And so in this case it would be A squared. In the upper left-hand corner, that would be this one. What is the area of this square? Well, we know it's B here, and this side here is also going to be B because we know it's a square. And so B times B is B squared. So what is the total area of the unshaded regions on D? Well, if we take a look at this, this would be AB, and this would be AB. This is A squared, this is B squared. So if we talk about just these parts that we shaded in ourselves, it wasn't shaded in, I know that the total area would be if I took my a squared plus my b squared. We know that this part is the shaded part. This is the white square. So that proves that a square plus b square equals c squared. It's the same amount of space. Whoops, too many. This is another way of looking at this. If you take a perfect square a, so if we have a squared, let's say it's let's say a is 3. And then we have b, and let's say it's 4. And then we want to know if it's a square plus b square equals c square. If this one I say is 5, is this going to be true? So I have 3 square plus 4 square equals 5 square. This is 9. This is 16. And if I take 16 plus 9, I get 25. 5 squared is 5 times 5 is 25. So this proves this right triangle. This is what you call a perfect right triangle, because you have 3 sides of the triangle that can form perfect squares. We can use the Pythagorean theorem to find the length of a side when you only know the lengths of the other 2 sides. So in our first example, we said find the length of the missing side. And so we have a right triangle with a hypotenuse. That's our unknown, isn't it? We have our short side, which we typically label as A, and then we have our long side, which we typically label B. And so we can take, I think they flipped it, but it doesn't matter, it works the same. So if we take a squared plus b squared equals c squared, a squared is 7 squared, b squared is 24 squared, and we want to know what c squared will be. So 7 times 7 is 49, and 24 squared is 576. And if I add the 2 together, I get 625 equals c squared. Well, that gives me what c squared is, but it doesn't give me what c is, does it? So in order to find what c is, I have to square root c squared, don't I? So if I'm going to square root c4 or c squared, I'm going to square root it, and I'm going to square root this, because remember, what I do to one side of the equation I have to do to the other. Well, c squared is formed by c times c, right? So c times c equals c squared. And so if I square root c squared, I get c. If I square root 625, I'm going to get 25. So c equals 25. And I will say that the hypotenuse is always going to be longer than your longest side of your right triangle. If it's ever smaller, you need to go back and check your math. This one's telling us what the length of the hypotenuse is. It says it's 25 inches. Oh wait, no, they're talking about this one. This one tells you that our hypotenuse is 17 centimeters, 15 centimeters. Boy, I'm really having trouble with numbers. And then this is just one of the sides. We can label it A or we can label it B. And then we need to find what the missing side equals, don't we? So I can have, I can use the same thing and just substitute in. So I have a squared plus b squared equals c squared. And we know that c is 15. B we don't know. And a is 12 squared. And it looks like they use different letters for theirs, and that's okay. This just goes to prove it doesn't matter which one you use for A or B. Okay, 12 squared is 144. bring down my b squared, and then equals, and then 15 squared, 15 times 15 is 225. And now simply get the b squared by itself. I'll subtract 144 from both sides. And then b squared is going to equal 81. Again, I'm looking for b, not b squared. So I'm going to square root to find b. And what I do to one side, I have to do to the other. So b squared is going to be b. 81 squared, or square root of 81 is 9. So square root of b squared is b. Square root of 81 is 9. So that means that my missing side is 9 centimeters. All right, so let's use what we know and find the length of the missing side on these triangles. We see the square in the corner, so we know that this is a right triangle. Because this is directly across from a right triangle, I know this is my hypotenuse. We're going to label it C. And then we're going to use a square plus b squared equals c squared. Doesn't matter which one you have as a, which one you have as b, it doesn't matter. You can just pick one and label it. So then we have 30 squared plus 40 squared is going to give me c squared. 30 squared is 900. 40 squared is 1,600. And when you add them together, you're going to get c squared. So 900 plus 1,600 is 2,500. And if I were to find the square root of 2,500, I'm going to find that the square root of 2,500 is 50, and the square root of c squared is c. So it's going, c is going to equal 50 feet. When I look at my next one, I see that I have again I have a right triangle. I have one leg, a missing leg, and then I have a hypotenuse. So I know what my hypotenuse is. I know what one of my legs is. My other leg is what I need to find. Okay? Again, just using my formula, a squared plus b squared equals c squared. I know that if I want to find a missing leg, if I subtract the square root of, so we used a for that one, I can find my missing leg squared. So that's what we're going to do. We're going to take 41 squared minus 40 squared, and that's going to give me my b squared. 41 squared is 1,681. My 40 squared is 1,600. And you have to remember that you're subtracting because you're taking c squared minus a squared equals b squared. And so I'm going to take my 1,681 minus 1,600, and I'm going to get 81. If I find the square root of each side of my equation, the square root of b squared is b, the square root of 81 is 9. So that means that b is 9 inches. So use what you know and find the hypotenuse on number 4. Once you've done the math, you probably noticed that you came up with a run-on decimal. 8.944 is the first 4 digits in the number. When you look at the instructions, it says surround your answers to the nearest tenth. So when I do that, The 4 tells the 9 to stay the same, so then it's 8.9 centimeters. Use your information to find the missing length of the leg on number 5. Once you've done your square root of your final answer, you'll find that it comes up to a decimal of 11.4891 and continues on. And if you round to the nearest tenth, the 8 tells the 4 to round up 1. So then you get 11.5 inches. Okay, the next one video that we're going to do, part 2, is going to talk about 3 dimensions using Pythagorean theorem.